Good morning, everybody, and thank you very much for joining us today. I'm very happy to have Philip Aldridge, the Chief Executive of NEPIC, with me today. And Philip is going to give me, or give us, sorry, an update on the process industry in the Northeast. Couple of house rules. Everybody's on mute. If you've got any questions, there's a box on the right-hand side on your screen which you can type in there to ask them. And what we'll do is we'll ask them at the end of the presentations. And after Philip's gone up foremost, we're going to have a catch up with Mike Ellner, our liquid waste manager, and Alec Llewellyn, who is our bioresources manager, to give you a bit of an update on that as well. So what we're going to do is I'll introduce you to Philip. So as I said, Philip is the Chief Executive of NEPIC. Originally from Leicestershire, he moved up to the Northeast to be a production manager at GSK. He's worked as a biochemical engineer for most of his career, which has included spells at the Centre of Excellence of Life Sciences, as well as doing various business development roles for SMEs as well as internationally. He joined NEPIC in 2012 and has been the CEO for the last 3 years. So thank you very much for joining us today, Philip. We really do appreciate you spending your time with us. And what we'll do is we'll save you some time. So we're just going to drop our cameras off, everybody, and I'll share my screen, and then that way you can see the whole of the presentation.
Okay, thanks, Andrew. Thanks for the opportunity for giving me some time to tell people a bit about NEPIC and what's happening in our region. NEPIC, the Northeast Process Industry Cluster, is an industrial cluster organisation, obviously in the northeast of England, extending from Stoke in the north of Northumberland. Can I have the next slide, Andrew? Yeah, so we're proud to say that we look after the biggest cluster of processing companies in the UK, and probably the second biggest in the whole of Europe. And what we do is network companies from the chemical industry, pharmaceutical industry, also in the supply chain, from big engineering companies to smaller supply chain companies, also the region's universities and the research technical organisations such as CPI. So what is it about clusters? I think it's well recognised academically that companies that exist within clusters do a lot better than organisations outside of clusters and that remain isolated, because there's many synergies to be gained from being within a cluster. Obviously, trade is an important one, but it's quite often you find that if you have a small SME who has an innovative product or service, they find it very difficult to know who to sell to in the bigger companies. Companies are usually pretty lean these days and don't have people who are able to do that horizon scanning to see what's about that could improve their processes and their business. So NEPIC brings people together, not only for trade but also for collective representation. We have a meeting next month with regional MPs and major manufacturers, so we can get the voice of industry direct to Parliament. We also have been doing a lot of influencing around the Freeport, for example, to make sure that a large proportion of the chemical industry is inside the Freeport and as such will benefit. We also work on common themes such as safety and training, etc. I guess a big one at the moment is decarbonisation. I'll talk a bit more about that in a minute. And also best practice. We obviously, in a big cluster, have a number of companies that are doing world-class things in different areas. And if we can share that world-class best practice throughout our membership, then everyone benefits. So hopefully you can see what it is about a cluster that helps and why you need an organisation, a sector cluster organisation like NEPIC, to bring these strands together, bring people together to share knowledge, enhance trade. Next slide. Yeah, so as I said, this sector is of a significant size. The chemical industry as a whole in the UK is very large, turnover of 50 billion. And I think it's estimated that 95% of all manufactured goods have some input from the chemical industry. So it is an industry of industries. So it's of vital strategic importance to the UK, and as we have the biggest concentration of chemical and pharmaceutical companies in the UK in the northeast, you can see that it's a sector well worth looking after. Next slide, please. Not only is the chemical and pharmaceutical industry is important from an economic point of view for providing work and a good livelihood for a lot of people. The chemical industry is also really very engaged with some major societal challenges in terms of global warming, plastics recycling, etc. And I think the other thing to mention is that chemical sites like the one where Northumbria Water are based on Wilton International Site, they're integrated complexes. So the outputs and products and byproducts from one factory are used as the raw materials for another, and there's also common supplies of chemicals, steam, and obviously effluent treatment, and obviously that's very important in a chemical facility as well, and that's provided by Northumbria Water. So you actually have this plug and play environment. So if a company wants to invest in a chemical factory for the first time, it's so much more efficient to do it on the Wilton International Site because of that plug and play environment. They don't have to build boilers, they don't have to generate various gases, they don't have to put an effluent treatment system in. It's all there for them. And I think what we want to do at NEPIC is leverage that. And I think we've got a number of things going on at the moment that will help us with that leverage. One is, I think, is around the free port. We've managed to get one of the 8 free ports in England, and this will provide, I think, probably the biggest advantages. It'll put us on the map globally as a centre for the chemical industry and for inward investment. But there are tangible benefits in terms of and other aspects that will help. So actually trading and building facilities will be much more cost effective on the Wilton International Site than they would be on other places in the UK. So that is a really big plus for our industry. I think the other major thing is decarbonisation and the net zero Teesside project that we're involved with as well. And this will involve building a gas-fired power station, which will have carbon capture with it. So all the CO2 that comes from that power station will be captured. But not only from that power station, but from all the large CO2 emitters from across Teesside, they'll all be piped in to that. And the CO2 will be conveyed in existing oil pipelines under the North Sea into depleted oil wells. That will result in yet another major advantage. We could become the first chemical cluster in the world to be decarbonised. So that as well will give us the advantage in terms of attracting companies to our region. At the moment, in terms of plastics recycling, and a number of the companies on Teesside are investigating plastics recycling or even building facilities to actually start recycling plastics. Plastics are wonderful materials, and the manufacturers of the chemicals that go into plastics on Teesside are not the people that are causing pollution. That's people that throw things away and send things to landfill. The manufacturers are part of the solution, and they want to take those chemicals back to repurpose them and to make more plastics from them. So I'm confident that the Wilton International Site and the wider region will become a centre in the UK for plastics recycling, helping industry, but also helping the environment. At NEPIC, we're also working with the Combined Authority and with the Centre for Process Innovation to look at new methodologies, new technologies to make chemicals, and in many cases make them in a green fashion with less CO2 emissions. And what we want to do is again attract new companies to the Wilton International site that can make use of that technology. So I think hopefully what I'm trying to do is build a picture that we're trying to use and utilize our traditional expertise, infrastructure and strengths, and add a lot more in terms of decarbonisation, a good business environment and new technology to make sure we grow the sector and keep existing manufacturers up to date and competitive. Within NEPIC, we've recently taken on 3 innovation managers, one to look after our pharmaceutical sector members, one to look more into the plastics recycling space and really map what we have and see what opportunities that there are and gaps in the supply chain, and also someone who's bioprocessing as an alternative technology for making chemicals, again reducing the environmental impact of the chemical industry on the environment. So as you can see, I think there's a lot going on that NEPIC can help with, and the future for the chemical industry on Teesside really is very bright. I think there's 2 other things I forgot to mention. One is that we produce quite a lot of hydrogen. Our plans to produce a lot more. This will be very important in terms of domestic heating, also for industrial processes, and also for input into chemical processes as well. And I think this is going to be something that is one of our strengths that we'll build on. And also up in Northumberland, we understand a company called British Volt is building a gigafactory to make automotive batteries. And there's a big opportunity there for the UK chemical industry to sell chemicals to these gigafactories, because they need a lot of chemicals to make their batteries with. So there's new markets opening up as well that we're keeping our eye on. So that's all from me, and thanks again to Northumbria Water.
Thanks very much, Philip. Really appreciate you spending the time to give us that update on that. It does sound particularly very positive in the sort of the process industry in the northeast, with lots going on there, from decarbonisation to electric batteries and everything else intertwined, and hydrogen and everything. So we seem to be in a really fortunate position, and hopefully there's a lot of people out there who could do with a bit more support from the likes of NEPIC. So just for anybody watching, if you're interested in either finding out more about NEPIC or becoming a member, you can just drop me an email at tws@nwl.co.uk, and what I'll do is I'll make sure you get to the right person in NEPIC who can take you where you need to be. So other than that, thank you very much, Philip. Really do appreciate it again. And then the next clip that's going to come up is going to be of Michael Ellner and Alec Llewellyn giving you an update on NWL processes. Thanks very much.
Okay, thanks, Andrew.
So I'll just do some quick introductions. So today I've got joining me Mike Ellner, who's our liquid waste manager. Thank you, Michael. And he's going to give us a little update on some of the upgrades that we've made to the Bran Sands treatment facility. And then I've also got Alec Llewellyn, who is our bioresources manager. And Alec is going to give us a presentation on how NWG deals with its biosolids once it's been through the process. So what we're going to do, without further ado, we're going to move on to the presentation. Now, what we're going to do is we're going to do this a little bit like the government update. So it's going to be a next slide, please. So it might take a second or two to come on, but don't worry, it will. And what we're also going to do is we're going to knock our cameras off just so you can get you can see the full presentation, because we've got some nice pictures on there which we'd like you to see. And then, Michael, if you can just start your presentation.
Okay, yeah, thank you, Andrew. And like Andrew says, I'm Mike Ellner, Liquid Waste Treatment Manager at Northumbrian Water's Bran Sands. And I'm going to specifically talk about our upgrades that we've made to improve the facility of dealing with your tankered waste. So next slide, please, Andrew. Yeah, so we often start these things explaining why on earth Bran Sands was here to begin with. And quite simply, it was to meet our, if you like, statutory obligations. We deal with all the municipal waste in North East England, and in particular on Teesside is what Bran Sands was designed to deal with. And one of the massive drivers was relocating it further upstream towards the estuary. So that's why we ended up picking Bran Sands to be located on the Tees dock. We also, at the same time, the company made a decision to create Train A, and that was to serve industry on Teesside, both now and in the future. And then we created a really good industrial customer base, and in a partnership. We improved 12 kilometres of the River Tees water, and if you're local, you'll know that there's a Tees barrage in Stockton, and the improvements that we made allowed that really to go ahead. At the same time, we took the decision to look at the tankard business, which some of you may even remember was done at Billingham, and that got moved originally to Bran Sands back in 2002. And since 2012, at the same time, we took the opportunity to upgrade the cess and septic. So that's domestic waste that we deal with in our domestic plant. And we upgraded that to one of these JRP loggers. And then very recently, this spring of 2021, we, if you like, fully refitted the tanker business area. So next slide, please. So that's how life started off back in '95. It was just a landfill site, would you believe it? So you can clearly see there in white the dotted line. That's the markings of Bran Sands. So next slide. Now this slide actually shows us what we are today. So you can imagine that was that landfill tip, and that's what we ended up building. And if you can look carefully, Train A will be highlighted in red. So if Andrew, you click that, we'll see there. That is Train A. So that is where all the industrial tankard waste, pipeline waste comes into Bran Sands. That's where we treat it. So next slide, please. So our location is ideal to serve the whole of northeast England, but also as far down as Liverpool, Manchester, Leeds, and we do have waste streams that we pull across from Scotland, down from Scotland. So there's a nice graphic here, shows you the main routes, the main motorways coming across the region, and you can see how nicely we are situated. Next slide, please. So here we are then, 1999, that's when the site first went live. And what you're looking at there is 2 balance tanks, and in particular, these agitated mixers. So they look like propellers. And would you believe it, that's what used to agitate and mix tanks for us. So all tankard waste would end up going through one of these tanks. So that's an old system. If we go to the next slide, please, Andrew. You'll see now a sort of new optimal, and this is an engineering drawing. Tankers now are actually injected into this tank from the opposite side of the takeout. That's quite important because it prevents any kind of short circuiting. But also now we've upgraded, so we've moved away from these propeller mixers to these jet mixers, which have these external pumps fitted on them, and there's 2 lots of nozzles and 2 pumps, and what we're getting is forcing the outside of the tank into the middle, and there's a very slight swirling of the tank contents. And again, because we have 2 tanks, we have duty standby. As we're filling one, we're emptying the other. If we have to do maintenance, we flip the tank, we can just go to 1 tank mode without any problems to your bookings, the way that I can mix and blend and pass forward. So next slide, please, Andrew. So yeah, those are photographs, and these tanks, if you didn't know that they're that huge, they're 3,200 cube each. So we have a combined total waste holding of nearly 6,500 tons. We process nearly 3,000 tons a week. So we spread that 7 days a week. If we've got bank holidays coming up, we can adjust this now. It really doesn't impinge or impact on tanker numbers and bookings. You can see there the new mixer pump on the left. These are quite meaty 15 kilowatt motors. There's 2 of them. And you can also see where we've repositioned the forwarding pumps. So that was quite key. That meant that we could totally prevent any kind of issue with mixing. Next slide, please, Andrew. So the acceptable wastes then, we've made this investment, we've upgraded. So what we can now do is pretty much what we always done. We can take a huge range of acids, typically sulfuric and hydrochloric. We deal with those up to 30%. And correspondingly to that, we also deal with a huge range of bases, typically caustics. They can be up to 20%. Potassium hydroxide, lime-based wastes. We also deal with ammonia now, and we've now got a limit of 10,000 milligrams per litre. So we will offload tankers with up to 250 kilos of ammonia there. We will still limit that, but at least it's to a couple of loads each week. We've always dealt with high strength wastes, and now we can actually improve on that, and we've now increased that to 120,000 COD. We've always had to accept clean, clear, waste-free of sediments and layers, and that's still the case. Although the mixing has improved that much, we are more forgivable of debris, solids around the 200 marks. And if we do get any total petroleum hydrocarbons, it's not a complete rejection. We've found that the new mixing even deals with those. Concentrated coloured waste, they've never been an issue to us. Again, the mixing has improved that much. We don't get any streamlining at all. And if I can direct you to our web page, you'll find our permit, and in there you've got tables with the full list of EWC codes that we accept and we treat, and we do with an awful lot of hazardous waste. Next slide, please. So I showed you photographs of these two huge balance tanks, 3,200 tons in each. We've got all week to process that. So now we can deal with 25 tankers a day quite comfortably. Some of you would have had local agreements in place with your cod and your ammonia, which was quite limited. These now have been increased. You'll have been contacted. We've done away with those. That was only a short-term measure that was put in place because of the building work that was ongoing. We've got our 4 tanker bays, and we've now got speeds of 25 minutes per offload. We've got a new site lab, and we've situated that within a short walking distance of the bay. So again, we're getting quicker, turning around your samples and getting the pre-acceptance done and out of the way, and getting your vehicles safely parked into one of the 4 bays. The daily high strength of tankers used to be capped, it was 2 a day. We've now increased that to 4. These really are huge tanks. The mixing is that improved that we can handle 4 of these high strengths now daily. And we've also increased our weekly total cod and ammonia loading capacities. And that's brilliant because that's given us an extra 20%. Next slide, please, Andrew. So there's also now some discounts, you'll be pleased to know. So if you're bringing in high strength CODs, traditionally you would have been charged for the entire COD load. We're going to work with you to work out what's best for us. If it's readily degradable, then there's going to be some discounts offered. We've also got discounts on guaranteed volumes, and there's now going to be some opportunities for some sort of medium-term contracts to guarantee volumes and keep those prices low, and that's typically on sort of low strength waste. There's also a simpler pricing now based on this banding, and a new exciting project. Bays 1 and 2 in particular are in a ETAX rated area, and the feedback I'm getting from the safety team here is we can comfortably move from a 40-degree flash point now to 35 degrees. So we're looking now at offering treatment of alcohol-based solvents. This investment that we've concluded means we've got higher flow pumps, and we're just getting quicker turnaround, and the whole offloading experience is improved. So we're taking 25 minutes to pump off. With a lab where it is now, it's 5-10 minutes to sample and test. So you're not hanging around on this site more than 45 minutes. Okay, next slide, please, Andrew. So, of course, what happens to your waste compounds then? Well, your carbon-bearing waste, 95% of that is removed. It forms our new biomass cells and also releases carbon dioxide in that treatment. The ammonia waste is 100% removed to nitrate, and again, also goes into forming new biomass cells. Interesting, your trace heavy metals. Well, these are actually nutrients for our biomass, and what they do is they're assimilated by this new growing biomass, and they also stick to the surface of it. And the resulting liquid phase that we separate out after the treatment is fully compliant with our permit and also the Dangerous Substances Directive. And the interesting bit then is, what do we do with that new biomass cell growth? And that waste is known to us as surplus activated sludge. And what we now do on site is we further treat and enhance that through this AAD plant, producing a rather rich organic product, which is recycled to agriculture. And Alex on next will explain those further to you. So thank you very much. Next slide, please, Andrew.
Thanks very much, Mike. Really appreciate that. And yes, as Mike just said there, we're going to move on to Alec's presentation now, which is on bioresources recycling strategy.
Yep, thank you very much, Andrew, and thanks, Mike. So now we're going to talk about what comes out of the AAD process. So next slide, please, Andrew. So what we're going to talk about very high level is, what is Northumbrian Water Group's bioresources strategy? Actually, what are or is biosolids? Something called BAS, which is the Biosolids Assurance Scheme, and that links to the legislation that we have to adhere to. And then finally, a couple of slides on how we physically recycle. So next slide, please, Andrew. So as you can see, this is a schematic of the northeast, and Mike's already explained that Bran Sands is down in the south of the region on the Tees estuary. We have two advanced anaerobic digestion plants, one in the Tees estuary and one at Howden on the Tyne. All sludge that's created by all 415 sewage treatment works within the Northumbrian water area are treated at these two sites, and the sludge is converted to biogas, which is a renewable energy, and then the enhanced treated biosolids, which we'll be focusing on a little bit later. Howden was also the biggest gas to grid plant in the UK when it was commissioned, and Bran Sands followed along there in mid-2020. Sludge is transported to these sites as either a cake or a liquid by Northumbrian Water Fleet, which is part of my remit. To make that more cost effective, we have an infrastructure of dewatering plants as well, so that we're not just moving liquid, we can actually dewater. And all sludge is transported by road. Next slide, please. Very simple schematic that I use quite a lot to explain the biosolids life cycle to our customers. So as you can see there, a nice little house and somebody goes to the toilet. We then have the 415 sewage works, which the sludge eventually gets to the AD plants. And we have something called power from poo, which if you Google on our website, you'll find a lot of information about, which is the gas to grid plants. And then approximately 110,000 tonnes of biosolids are spread to land every year in the Northumbrian water region. Next slide, please. I've just explained it's a cycle, but it's also a linear process, and it's very much a just-in-time delivery, so that any interruption on any of these processes has both upstream and a downstream impact. So, for example, if there was a problem with the AAD plant, I couldn't bring any extra sludges in, which would stop my centrifuges, which mean my tankers would have to park up, which ultimately would have an impact on the treatment process. But also as well, if I wasn't producing enough biosolids, I wouldn't be able to produce the customer demand that we have in the agricultural region. So it's a very difficult and complex process to manage. Next slide, please. Roughly in terms of volumes, I know Mike talked about the import volumes. These are in tonnes dry solids of sewage sludge that comes into Bran Sands, and the ETW is the effluent treatment works at Bran Sands that produces about 11,000 tonnes dry solids per annum. I bring in about 5,000 dry tonnes in terms of liquid, and that's from the local sewage treatment works in the Tees area, for example, Seaton, Carew and Mask. And then I also bring a vast amount of sludge in from right across the region in terms of cake. So as you can see down the left-hand side, those are the sewage treatment works that they come through. That goes through the AAD process, and approximately 30,000 dry tonnes per annum, which equates to roughly 60,000 wet tonnes of biosolids cake to land. Next slide, please. As I said earlier, Northumbrian Water has the two sites, so each produce approximately 60,000 tonnes, so I have up to 120,000 tonnes per annum, and that all goes to agricultural land. And as Mike said, it's a rich agricultural product, specifically in nutrients, N, P, K, magnesium, and a little bit of sulphur. Next slide, please. I don't particularly want to go into the detail of this, but just to say that we follow best reduce, reuse, recycling legislation and guidance, and biosolids is recognised as recycling to land is consistent with the circular economy as well. Okay, next slide, please. So I've talked a lot about biosolids. So what actually are biosolids? So they are the stabilized, which is key, and then the nutrient-rich organic material produced at the end of the AD process. And the key thing here is it's stabilized, and by doing that, we reduce the pathogens and minimize odors, so it's a safe and natural agricultural product. Next slide, please. The key element of that is the reduction in the pathogens, and legislation allows 2 types of biosolids to go to land: conventionally treated or enhanced. The AAD process that we have at Bran Sands and Howden is the CAMBI process, which allows us to treat enhanced treated sludge. And as you can see by the second bullet point there, you can actually see the reduction in E. coli, which we use as an indicator to say what else is being killed, and also the absence of salmonella. And we have always, with the AD plants, produced an enhanced treated product. Next slide, please. So as you can imagine, we are very heavily regulated, and introduced in 2016 was something called the Biosolids Assurance Scheme. And this was intended to provide reassurance specifically to the food chain and agricultural customers. So it attempts to achieve operational transparency and consistency, to demonstrate the benefits of nutrient delivery. It obviously protects the environment, provides information to not only our agricultural customers but the general public as well, and provides the key stakeholder reassurance. So BAS has been an exceptionally well received assurance scheme, and it's been accepted by people like Red Tractor and the National Farmers Union. Next slide, please. As I said, the Biosolids Assurance Scheme tends to tie everything together, but there's some specific pieces of regulation that we have to specifically follow. The key one is the sludge use in agriculture regulations that allows or demonstrates what heavy metals, etc., are in our product and what our application rates could be. HACCP or HACCP is the hazard analysis with critical control points, and is key in helping us to ensure that we have the actual pathogen reduction that we need. And there's several other things on there, like the safe sludge matrix, NVZ, which is nutrient vulnerable zones, and fertilizer management guidelines RB209. Next slide, please. The safe sludge matrix is probably the key document. It was established by the British Retail Consortium, and again, it's to assure stakeholders that where we are putting sludge is safe. And as you can see on the far right hand side, enhanced treated sludges can almost within reason go on almost any crop type. Majority of the sludge in the region is put onto combinable crops, so that's the likes of wheat, oats, barley, and oilseed rape. Next slide, please. And we have to adhere to RB209, which is the nutrient management guidelines that allows us to ensure that we're only applying the correct nutrient needs to the crop type that the farmers are growing. Next slide, please. This is how we recycle. Again, a very simplistic schematic, but just to show that everything is really well managed and controlled. So we have to create a sales order with a FACT qualified person. FACT is agricultural advisory performance. So we also then follow risk assessment guidelines. We have to do soil sampling to ensure that the nutrient baseline is correct, and then the application rate is associated with the biosolids. It's delivered to field, stockpiled, and then post-harvest, the farmer lets us know when we need to incorporate into the soil. Next slide, please. We branded ourselves as NW Grow, and you may see some of the vehicles driving around the region. I've got 4 of these 8-wheeler tippers, and we're generally on the road Monday to Friday, 6 till 5. Next slide, please. I'm conscious that I've gone through a lot of the regulation very quickly, but as you can imagine, there's a lot of data and a lot of data points that we need to record, and that's recorded in our system called Gemini. So every single piece of sludge in the region is recorded, so we know exactly where everything has gone, and we use a series of maps and dashboards to actually explain that. Next slide, please. under the biosolids assurance scheme and also with our ISO quality standards, we need a process flow. As you can see there, that's just the top bit of the process flow. I don't propose to go into it, but you can see where we have control points and action points. And again, this is demonstrable in the biosolids assurance scheme audits that we have every year. And next slide, please. And finally, the last slide here just shows that every single deployment we have to a farm actually has an associated risk assessment. That's necessary to ensure that we're following all pertinent regulations, but also best practice and taking into account customer issues and habitation, as well as soil types, etc. So every single stockpile has one of these risk assessments again, which is recorded in our Gemini database system. And next slide, please. I'm conscious that I've probably rattled through this, and I'm sure there'll be further questions, but thank you very much for listening.
That's brilliant. Thanks very much, Alec. Guys, do you want to just put your cameras back on? And what I'll do is I'll stop sharing that screen so you can see us in full in all of our glory on camera, as we all like to be nowadays. So yeah, thanks very much for the presentation. Really appreciate it, and I'm sure it's been really informative for the viewers. We got a couple of questions that came in sort of pre this, and the ones that I suppose will probably get asked quite a lot over and over again, a bit like a frequently asked question. So what I thought was we'll just quickly go through them, and then Mike and Alec can kind of give us an answer to those. But again, at the end of this, what we'll do is I'll get a slide on there which just has our contact details, and if you've got questions, fire them through to us. I'll make sure they get to Alec and Mike, and we'll get you some answers back going forward. So the first question that came through was, so does Train A comply with the new BREF note for industrial waste, Mike?
Yes, certainly does. We actually were compliant to BREF a few years before the period that we needed to, which we're quite proud of on site. So certainly the nitrification, the ammonia consent was always reduced ahead of the BREF coming online. And that's certainly the same with the solids and the COD. So yes, very much a BREF compliant plant.
Brilliant, thank you. You mentioned during your presentation about the lowering of the flash point from, I think it was 40 Celsius down to 35. It's welcome, but some solvents have like sort of low concentration, which will still produce that kind of layering effect. Will this be, sort of acceptable, basically?
Yeah, I mean, we've always told our customers the best thing is to always make an inquiry with us, and we look at things very much on a case by case. And certainly recently we've learned that in particular a subtle oil layering does not seem to appear within these new mixing tanks. So the important thing for us is that we can now keep things very much mixed and in suspension, and we've shown in our pilot plant that that's not causing any problems in the main aeration cell, which is where all the activity occurs. As soon as we can get that biomass into this stuff, it's changing, it's transformed, it's not going to layer out. So yeah, I'm pretty confident we may be able to look at certain layering of these solvent layers, but we certainly understand that the alcohol-based stuff is fully minceable anyway in water. But yeah, definitely we will look at those for people. Absolutely, yeah.
And then we've got a question that came in, which was around sort of is acid and caustic still booked in on separate days?
Oh no, that's a good point. Yes, no, there's no need to do that now. With 4 bays, what we intend to do is keep you separated away from each other in separate bays, so we don't have to do that anymore. Yeah, no, that's finished. So yeah, we can do simultaneous and multiple days the same. Absolutely.
That'd be good. And then sort of the next questions around sort of, kind of are odorous waste still acceptable in the open tanks?
Yeah, we have to be a bit careful with those, but we're pretty good with odorous material. We do have streams that do have a bit of a pungent odor to them, and we certainly don't detect those outside of the site boundary. And we are blessed in our location is very industrial, so it's understandable, but certainly case by case we have to assess those, but we've not seen problems to date, no.
And I assume that would be the same thing as to kind of just inquire and ask the question, and we'll
Absolutely,
work with you to
yes.
kind of find the
Yeah.
answer.
Yeah, absolutely. Yeah, definitely. Yeah.
Brilliant. And then we've got one for Alec here, which is, has NWL got the ability to move liquid waste from production sites to NWL Bran Sands, etc.?
That's a really good question, Andrew. That historically Northumbrian Water had a closed operating licence for its vehicles because we just moved our own sludge, not for hire and reward. But that changed last year. So we are looking to get into a commercial environment. And if any of you, the people who are listening today, I'm sure if they'd want to speak to you and Louise, we would look at the case-by-case basis.
Excellent, brilliant. And then we've got one final question for you, Alec, which is, can some waste be treated directly via the ADD?
Again, that's a really interesting and probably a complicated question and answer. So I'll try and summarise it. Currently, biosolids are recycled to land under the sludge use and agriculture regulations, which is on one of the slides, and that's specifically for sewage sludge. So anything that comes out of a sewage treatment works that goes into a sludge site, I can recycle to land. I'm sure Mike will be able to explain a lot better than me, but we can treat things in the AD plants. However, I can't recycle currently under sludge use and agriculture regulations if I introduce waste to the actual digestion process. So the short answer currently is no. However, the longer answer is please come and talk to us, because the EA, our regulators, are currently reviewing the sludge strategy and the associated sludge regulations with a potential view to change to more of an environmental deployment type approach. Now that might mean in the next year or two we can actually put industrial waste directly into the digesters. So currently we can't, but potentially we will be able to. And again, I'll refer to you guys, speak to Andrew and Louise and see what we can do from there.
Brilliant, thank you very much. Well, that takes us to the end of the questions that we have, and I can't see any other ones that have come through. So basically, we'll draw to a close. As always, thank you very much for spending the time with us. We do appreciate it. We know everybody's busy, and to take half an hour out to listen to us kind of talk about ourselves a little bit is always welcome. Again, you'll be able to get in contact with myself or my colleague Louise Morritt, and what I'll do is I'll put a slide on the end of this so that you've got those contact details. But I suppose the resounding key point of this is, if you don't know, ask us. We're here to help, we're here to support, and if we can help you get rid of your waste and deal with that in a cost-effective and sustainable way, then that's exactly what we're here to do. So without anything more to say, we'll just say thank you very much and goodbye.
Thank you.
Thank you.